Impedance of electromagnetic wave. Impedance means resistance. The resistance or hindrance offered in propagation of EM wave is called impedance. Denoted by Z. Resistance or hindrance offered in the propagation of the electromagnetic wave, and that is denoted by Z, and its unit is ohm. Unit ohm, or like this. This is the symbol of the ohm. Since this is the resistance, resistance is measured in the ohm. So this is the unit of this impedance. The impedance of EM wave in free space is the ratio of electric field E to magnetizing field H. So now we have this, the Z naught equal to E naught upon H naught. Now its magnitude. This is now E naught, that we denote in case of the wave when this is traveling in the free space. And now this Z naught is equal to square root of mu naught upon epsilon naught. So this is the formula of this one, and this we got by this formula. And now if we put the value of, now here mu naught is equal to 4 pi into 10 raised to the power minus 7, and this is a Newton per ampere meter square. This is now Weber per ampere meter, and epsilon naught, this is equal to 8.85 into 10 raised to the power minus 12, and Coulomb square per Newton meter square. So if we put these values in this relation, then this Z equal to 376.7 or 6, I think. Three 76.7 ohm, or this is equal to 377 ohm, approximately so much. Or this Z equal to this, we can also express it as 120 pi. So this is what the impedance offered in the free space to the propagation of the electromagnetic wave. 120 pi ohm. If we express in this, then we can write to this one. So these are the impedances in the free space. But when there is some medium, traveling in medium, then this impedance Z equal to square root of mu upon epsilon. Mu the magnetic permeability of the medium, epsilon the electric permittivity of the medium. So now we can have that this mu is equal to mu r into mu naught, and epsilon equal to epsilon r into epsilon naught. So now we can put these values here, and we can have this Z. Z equal to square root of, this is now your mu r mu naught upon epsilon r into epsilon naught into epsilon naught. Now in dielectric medium, mu r is equal to 1. So we take the dielectric medium. Mu r equal to 1. So we can have this Z equal to square root of mu naught upon epsilon r into epsilon naught. So this is equal to Z naught upon square root of epsilon r. This is equal to Z. So now from here you can see that this impedance depends upon the refractive index. So this mu naught epsilon r, this epsilon r is square root of epsilon r, this is equal to the refractive index. So this Z equal to Z naught upon n, where n equal to square root of epsilon r, the refractive index. Of medium. So now we can have that as Z increases, then as N increases, then this Z decreases. So now we can have that in good conducting medium, now this the refractive index epsilon r equal to infinity. So this n is equal to infinity, so now we can have that this z equal to 0. So z equal to 0. It means that no impedance is offered by the conducting medium when the electromagnetic wave travels in it. So this z equal to 0. Except to this one, now we can having this z. Now this z equal to E upon H. In the medium we are talking, so this z equal to omega mu upon k, where omega equal to 2 pi nu, the frequency, angular frequency. Angular frequency. Mu the magnetic permeability of the medium, k the complex wave number, k complex wave number. So now this k, the complex wave number, depends upon the medium. So you can see from here that this z, as the wave goes away from the source, it decays very fast. So this impedance also depends upon the physical properties of the medium. Wave the electromagnetic wave decays when going away from the source. Away from the source. So this z k increases. So this z increases, because of that the wave decays very quickly. So when we are having such medium in which the value of k is large, then the wave cannot travel through a large distance. So we can have that the impedance depends upon the physical properties of the medium. So this is about the impedance of the electromagnetic wave, and this is the formula. These are frequently asked the multiple choice questions. You can answer it easily. So thank you very much.